Morning, everyone. A very good morning to all of you. I hope you got some time to complete or solve yesterday's assignment. So has everyone tried the array of references, that point array-based assignment? Okay, completed? Is it completed? Okay, great to hear that. Very good. And has anyone started with the inheritance-based, that fruit-based assignment? Okay, that is also very good. Completed is very nice. So anyway, we will revise that. And at that time, if anyone says that, okay, they need help, we can solve it together also. So what is it we are going to do today is next two important topics, polymorphism and time permitting inter abstraction. But before that, we always revise important concepts of yesterday. So let's start with that. The highlight of yesterday was inheritance. So we'll revise from that. So why inheritance? Everyone knows. Reduction of redundancy, or to reduce redundancy and increase or enhance reusability. Everyone knows the reason behind this. Why inheritance? So tell me verbally, which is the keyword which Java uses to bind a subclass to a superclass? Extends is a keyword. What is the name of the universal superclass in Java, since it follows the single root inheritance hierarchy? Object class. Which is the method of the object class you have seen, which we had inherited and then overridden? ToString method. Very right. So which is the what is the name given to the classes in the upper hierarchy? Superclass. And what is it? Yeah, parent class, base class, anything. And that one in the lower hierarchy is called as subclass. And when you say, I'm going to modify the behavior. So this modified behavior, will it appear in a superclass? Yeah, method overriding. Will it appear in a superclass or in a subclass? Of course, in a subclass. Okay. Now, then we had also discussed what are the different types. So tell me, single inheritance. Give me an example. Any example will do. A extended by B. So the arrow is on the other side. The arrow is on the A side. So A is extended by this. Employees extended by manager, fruit by mango. All five. Mango extends fruit. Give me an example of multi-level hierarchy, please. Yes, Kunal's directions are right. A extended by B, extended by C. Or employee extended by manager, extended by HR manager. Or you are a student and a graduate student and a postgraduate student. So you can think of so many, what do you say, real life examples. But okay, so these two inheritances are supported in Java. Which is the inheritance which is not supported is multiple inheritance. Okay, and it is not supported for the purpose of removing the ambiguity. So yesterday we had just it's a diamond issue basically, right? So here now today after solving or after discussing that toString overriding, or in the fruit class I had asked you to override test, you will understand what is that diamond issue. Yesterday was too early for that, so I did not show you. So here, I think yesterday itself I had given the memory diagram, not memory diagram, sorry, the example. So what is the so-called issue? Problem with the multiple inheritance. If it is allowed, which Java does not allow, that's a separate story. It causes classic ambiguity. So understand it with an example, always better. Suppose you have written a superclass A, which has a show method, public void show, and you have SOP'd one. This is a very easy example to reach. A is extended by two subclasses, class B and class C. So you know now the keywords and everything. So now this should not sound difficult at all. So here you have class B extends A, class C extends A. So can you override? Can a subclass override the functionality, modify the behavior which it has inherited from the superclass? It's a yes or no question, Boolean question. Of course, yes. So class B has overridden the show method. Class C also has overridden the show method for its own specific, with its own specific implementation. So if Java, see, if you say, the moment you say class D extends B comma C, Java compiler gives you an error. But suppose, so that is what we mean when we say multiple inheritance is not allowed, not legal in Java. But suppose it wasn't, it was allowed. In short, in C++ it is allowed. Class D extends B comma C. What would have been the ambiguity here? Anyone wants to answer? What is the ambiguity? What is that diamond issue? What is that ambiguity you would have faced? Let me see what you are saying. The show method. Okay, so the correct complete answer is class D is totally ambiguous, or it doesn't know exactly which show method it is inheriting. Is it inheriting the show method from class B, or is it inheriting the version from class C, causing confusion, causing ambiguity? So of course, in C++, there are ways to remove this ambiguity. I'm not saying dynamic cast operators and all that, but the point is, I'm not talking about that. Java is a simpler language, more robust, easier language than C++. So Java compiler, to remove this ambiguity, does not allow you this. Anytime you're in the lab, with ID, it takes you a minute. Create this hierarchy, and the moment you try to inherit from multiple superclasses, 100% you will get a compiler error. And why it is called as a diamond issue? Can you see this diagram forms a diamond? That is the reason they call it as a diamond problem. So tell me, not duplicate data, Madhuri. It is the, what do you say, ambiguous. It is the ambiguity in deciding which method you are inheriting. So there's no duplicate data here. It's a method definition which is duplicated, which is ambiguous. I hope you understood me. Okay, so this is what is the diamond issue. Is everyone clear? So that is why what Java makes a decision to remove, to not support multiple inheritance. But practically speaking, you need the mechanism to inherit or to implement the behavior from multiple supertypes. I'll give you an example. Here, suppose I talk about a student, or I talk about an employee, anything. Let's talk about employee. So employee is the one who is working for a particular organization. But as an additional extracurricular skills, employee can be a sportsman. He may be a good football player. Employee may be an artist. He must be a good painter or good, singer or performer or whatever. So if I try to say public class employee extends sportsman, comma, artist, it won't allow. But then how to take care of such problems? Wait for tomorrow, where we discuss another very important concept in Java called as interfaces. So don't worry, you are not restricted by this issue. You just have to wait to learn the interfaces, and we'll see how interfaces allow you multiple inheritance without causing the ambiguity. So all of that tomorrow. Then this is still a revision. So then we had talked about constructor invocation in the inheritance hierarchy. Okay. So before I show you the diagram, just as a summary diagram, you know, there are two keywords. One is this, one is super. So super is a keyword in Java. And you have exactly two usages, two use cases of super keyword. One use case is to invoke immediate superclasses matching constructor. So anyone wants to tell me, what do I mean by matching? Matching with what? Matching what? Matching the signature, the argument list. Okay. So the argument list has to match with the superclass constructor. And in yesterday's example, when we are solved, person extended by student, person extended by faculty. So in order to initialize the private members which are not accessible in the subclass, we had used this syntax in the faculty or student constructor. First statement was super, first name and a last name. So what is the one usage of super? To invoke immediate superclasses matching constructor. Can a grandchild directly invoke the grandparents constructor? Absolutely not. There's no super or there's no such keyword. So if you have A extended by B extended by C, in C when you say super, whose constructor you will call? B. And in B when you call super, whose constructor it will call? A's constructor. Everyone clear? That was one of the usages. What is the another usage of super keyword? Guys, I hope you are finding it exactly same as this. This means current class at the current class level. Super means immediate superclass. Okay, so what is the second use case of super? To access super classes, read this twice, accessible members, visible members. So if you remember yesterday's example, we had overridden toString method in person as well as student. But in student, without writing getter, could we get the first name or last name? Answer is no. So there in the student's toString, we simply call super.toString. And when you say super.toString from the student, whose toString it will call? Object's toString or person's toString, O or P. Whose toString it will call? Of course, super means immediate superclass. So person's toString, and that is how we were getting the first name and last name related details. Okay, so after we discuss super, now just have a quick look at summary. This is all in revision. So take a look at constructor invocation. It's a favorite question. So spending revision time also on that. So have a look at it. I like to write it as a flowchart. So without reading too many books and all that. By the way, I have supplied you with a lot of ebooks on second day, I guess. So invocation of constructors in the inheritance hierarchy. Okay. So read the title, constructor invocation in the inheritance hierarchy. Now read this along with me. Understand this flowchart along with me. You are in a constructor of a subclass. Okay. So there are two parts. When I say subclass, you can relate it to your fruit mango hierarchy. So suppose you are in the mango. You are in the class, in the subclass mango. Or if you want, you can think of it as a student or a faculty. So there are two options. Subclass constructor is not added explicitly by programmer or added by programmer. So look at one case at a time. So tell me, when you don't add any constructor in a subclass, who will provide you with what? I said, when you don't write any constructor in a subclass, who will provide? Java not JVM, wrong answer. Java compiler provides you with the default constructor. See, Java C provides the default argumentless constructor. And what will be the first statement of the default subclass constructor? Answer is super. Okay, so that is all implicit. So now here, if your superclass does not have this default constructor, it is a missing constructor and not matching constructor, compiler error. But if you have the default constructor in superclass as well as subclass, that particular constructor is invoked. But what is the disadvantage of this? If you follow this branch, which of the following will be initialized? Your choices are first name, last name. And for student, suppose it is marks. Which of the fields will be which of the fields will be initialized? None of them. All of them will be initialized to the default value, first name, last name null, and the student marks 0. That is why we don't use this branch. But if you see a question in exam or interviews or whatever, you should know what happens. So now come to the more important practical branch. So we will add a constructor in a subclass. You remember we had added it in the student class. And Now say you have not invoked explicitly super. So again, you fall back to this option. Java compiler inserts a call to super. And if there is a matching superclass constructor, that constructor is invoked. Otherwise, you get a compiler error. So which is the branch which we want to be all the time? We will add a parameterized constructor in the subclass, and we will we will invoke super with the matching signature. So the moment you have called super with first name, last name, or if you have solved that fruit and mango example, super, color and weight, something was given. So then it will try to call immediate superclasses matching constructor, and the complete state of the object, including superclass data members as well as subclass data members, will be completely initialized. So tell me, openly, honestly, the complete discussion about constructor invocation is clear? All branches in the flowchart are clear? Great. So now let's go to the next point of revision. Yeah, so I had made a important statement yesterday. Subclass, okay, sorry, before I talk about it. When you talk about inheritance, what is the relationship between the objects we are imposing? Uses a, has a, or is a? Answer is a. Okay, so unless and until you can find out the common features, or you can exercise is a relationship, do not apply inheritance. So today, tomorrow, first 6 days are basic core object-oriented principles. Then I'll show you association, containment, composition, aggregation, and lot more stuff. So today we are not learning, we are continuing with is a relationship, and we are bringing in polymorphism also to it. So coming back to the point, this is my summary statement. So I'll be giving you a lot of such summary but important statements. If you understand and apply them, your comfort level will grow. So subclass is a superclass. Mango is a fruit. Student is a person. Loan account is a bank account types. But subclass, a child class, can it add additional data members as well as additional functionality? It's a yes or no question. Of course it can. For example, in student we had said year of passing, graduation year, marks obtained, etc. We have not yet added additional functionality, but soon we will add. And is there a possibility that you are inheriting something? Inheriting something means, let me be specific, inheriting a behavior from the superclass, but it is not suitable. So can you modify the existing inherited behavior? Answer is yes. And that is what you have started learning using method overriding. So example is required. So here, tell me, when you talk about toString, can anyone tell me whose method it is? It is a method of which class? It's a method of java.lang.object class, which is the universal superclass. Java, unlike C++, follows single root inheritance hierarchy. All the classes extend from object. And when you say okay, so people ask you, these are 5 are very important and famous methods. ToString equals hash code, compare and compare to. So you have to be like fully comfortable in that. Next one. So when you say public string ToString, what are we talking about? Here, this is what will this object classes ToString method return? Anyone wants to tell me? If you don't override it, what is it is going to return? You know the answer. Yeah, not just the hash code. What does it return is fully qualified. Class name, @ hash code. And what is that hash code? Hash code is nothing but the internal memory representation address where your objects are sitting in the heap. Okay. So famous next question is, what is the need of okay, let me ask you. So if you don't override it, you are going to get this. So what is the need, popular question, of overriding your ToString method? Anyone wants to tell me? Why did we override it? Yeah, but which modification? Overriding means modification. But for toString, why we overrode it? To replace just the hash code returning version by actual state details. Sorry. So this is for replacing or replacing the address printing version. Fully qualified class name @ hashcode is not useful in the practical scenario. If I say a fruit, I should see the fruit color, fruit weight, and maybe test if you want. So, depending on what state, whatever information, we want to replace the hash code returning version by actual state details. So before yesterday, we were writing our own methods, get point details, get box details, get employee details. But why go non-standard when object class has already given you the standard API? So from this point onwards, anytime you want to return the internal state details, it could be a private, tightly encapsulated state, always we are going to follow override toString and do the job. Are we all 100% clear? You got this? Okay. So now, example makes it clearer. So take a look at example. Suppose I have created a package named the bank. You got bank account is the main thing. So I've got an account class and the account status maybe, of course, account has an account number, customer's name, account balance, and account type. Okay. So if I do only this much, of course, there is a suitable constructor. So imagine all of this. I'm not going to waste time writing the code. So here in tester, if you create an object of account, LHS is the account type of reference pointing to the account instance. And if you say SOP A1.toString, okay, so what it will print? If you have done only this much, will it print the hash code version or will it print the actual details? Answer is, of course, it will print the hash code version. So how do you replace it? This is where you start overriding public string, toString. Of course, there are rules of method overriding and all. That will be our first topic of today, entering polymorphism. And here I can say return. I can say bank account details or some such header. And then I can say account number and other details. When I say dots, what I mean is the other state. So now, the moment you override the toString, here, whose toString this statement will call? Objects toString or bank account toString? Of course, JVM goes by the type of the object. So which is the object you have created? Bank account. So it will definitely call bank account toStrings. And here you will actually get account details. Is everyone 100% clear? This is where we finish the revision. This is where we complete the revision of important topics. So can we override any built-in method having is a relation? That is what we are doing now, Kunal. Between object and a person. Person is an object. That is what we have been doing. Anyway, I'm going to enter the method overriding and all in detail soon. The answer to your question is, of course, yes. That is what we were doing yesterday whole day. With is a relationship itself, we were overriding the methods. No, Vinod, I have yet to tell you the rules about method overriding. So stop asking questions at this point. I mean, its answer to your question is no. Okay, so tell me honestly, does anyone need any help regarding solving a fruit-based assignment, or have you understood it? I need a quick answer. You have understood it? Nobody requires help? Okay, so now we'll continue. And by end of today, you will find that assignment very easy because you would have learned much more. So now we are entering. We have actually entered the second part, but I have not given it in a formal manner. So now we are entering formally another object-oriented programming principle, namely polymorphism. So it is mentioned in the same README. So I've just copied that README in today's help also. And here You can look for the keyword polymorphism. Okay, so now start understanding it in this in a very clear manner. Let me make a statement. Inheritance alone is not so powerful, but when you have inheritance and something called as runtime polymorphism, based on that, all so many frameworks or so many further Java concepts are based on that. So today you are going to visit a combination of inheritance and polymorphism and understand the terms such as upcasting, downcasting, and applied to a real use case, applied to a practical scenario. Okay, so that's what we are starting. So what is the meaning of this word? It's a Greek word. Poly means multiple. Polymorphic is multiple forms. Typical example they give it as, if you talk about carbon, then it has got multiple forms. One can be a simple graphite, one can be a diamond. So the basic constituents are the same. It is consisting of carbon. So multiple changing forms, modified forms, one functionality and different forms. Okay, so this is called as polymorphism. Is polymorphism applicable to data members, behavior, both or neither? Pick up your option. Answer is wrong. Both those are saying are wrong. There is nothing like polymorphic data members. Data, when you have duplicate data members, there is something called as data hiding which happens. So polymorphism is applicable only to functionalities or the behavior, right? There is no polymorphism applicable to data members. Regarding data members, data hiding, I'll discuss later. So now there are two types of polymorphisms. One is called as static form of polymorphism. And when you say static, who is going to detect out of 10 different methods, which method to choose for execution? That is done by the compiler. So static form of polymorphism is called as is detected by the compiler, resolved by Java compiler. So it is called as compile time polymorphism, or it is also known as the famous term early binding. There are two terms you're going to come across: early binding, late binding. So I'm talking about early binding currently. Okay, so early binding means what? Early binding means which method to be called, which is the method to be used for execution. This decision, who is going to take? You have two choices: Java compiler or JVM. You know there are two entities. One is Java compiler, one is runtime. Answer is Java compiler. So this is your method. Okay, sorry. So how do we achieve? What you have seen with toString is not this. That is runtime polymorphism, which is more important. But I should cover all the topics. So here, this is achieved via method overloading. Anyone wants to tell me any example? You have already seen examples of method overloading. Anyone wants to tell me that this is where we saw method overloading? No. Come on. Add is your method. I'm talking about Java API methods. Okay. ToString is a wrong example. Constructor overloading, I had used the term. I will accept only the answers print and println. Main is not an overloaded method. All wrong. So guys, open Java docs. Open Java docs quickly. This should be open, right? I told you, right in the morning this. So here, when you say system class, java.lang.system, you know, you have system.in, system.error, system.out. What is the data member of system.out? Print stream. So click on print stream. I'm not going to repeat this. You have to match this speed at least. I'm not asking you to write anything. I'm just asking you to click on the things and be there. So here, if you search for print method, tell me, can you see a single print method or multiple? Simple question, simple answer. Multiple. And what is the same in that? The name of the method is the same. So we know that I told you. I will get back with your to your question in a while. So, but what is changing is the method signature, is the method argument basically. Okay. So this is an example of overloaded methods. Similarly, if you search for println, look for println, and you will see, what will you call them? Are these all overloaded methods or they overridden methods? Answer is method. This is what is the example of method overloading, changing signature, changing the argument list. Next one. Now, anyone has a good memory where you can see, you can tell me where you have seen it. In arrays class, guys, I have shown you toString. Open that, because you know, more you explore, more you understand. So here, open that arrays class. Somebody, when they said toString, maybe they meant that. I don't know what they meant. So if you want to answer me clearly and want me to understand, you should have said arrays.toString. I would have understood that. Okay, anyway, so look for toString method. Don't look at deep toString. Deep toString is not overloaded. There's only one version. Tell me, are you looking at the single toString method or multiple? Simple question, simple answer. Multiple. Are they overloaded or are they overridden? L for overloading, R for method overriding. Of course, overloaded, because the changing signature. Are you understanding this? So now note down when I say now understand the rules of method overloading. So before I tell you the rules, who is going to detect? Listen to this clearly. Who is going to decide which form of the method to use for to send for method execution? Is it the Java compiler or is it the JVM? Answer is Java compiler, because it is compiler decides everything by the type of the argument you are passing. So suppose I pass array of integers. You know, I have created an integer array and I pass it to arrays.toString. Compiler will fit it to the signature and will call it. I mean, JVM will call it later, but compiler decides. Instead, if I pass the character array, this will be sent instead. Are you getting it? This is what I meant. So here, read this. I'm sorry. Read this again. This is your compile time, or this is, since it is resolved by the compiler, it is called as early binding. What is this binding? The binding is nothing but the which form of the method to be sent for execution. Which method is bound for a particular call is your method binding. So that is done right early in the day, decided by the compiler. So now, most important statement. Are there any rules for method overloading? 100% yes. So the first thing is, can the overloaded method belong to the same class? It's a Boolean question. Can you write one class and add tons of method overloaded methods? Of course, yes. Example, print stream has so many print methods, overloaded print methods, println methods, arrays class. Similarly, can you write a method in a superclass and overload it in the subclass? Answer is yes again. So that is also possible. So note the rules, remember the rules. When you talk about method overloading, method has to have the same name. Okay, so otherwise, how will you say same functionality but multiple forms? It has to have the same method name. Later, I'm going to explain runtime polymorphism. Of course, this rule doesn't change. Next rule, the signature, method signature. For overloaded methods, same or different? S or D? Of course, it has to be different. So when I say different, what all can be different? Either number of arguments can differ. So you have a show method, which says one method as show int I. Another method show with int I1, I2. Is it overloaded? Yes. Number of arguments are different. Next one. Number may be different, or the type of the arguments may differ. Means what? You have got one method show with int I. You have written another public void show with double D. So tell me, are they correctly overloaded or not? Answer is, of course, correctly overloaded. And can I change both? For example, one show method, I've got you examples, has int. Another one has double and a boolean. So number is also different and type is also different. Again, it is considered as a different signature. And of course, it is a correct overloading. And the last but not most important, but yes, important thing is, how about the return type? Answer is, while choosing the correct form of the method, return type is totally ignored by the compiler. So this return type is not considered for resolving the overloaded methods is the statement. So just a second. Okay, so this is the statement. So now start solving. In the today's lab, I'm going to give you some ready-made code samples as always, and we'll discuss the output and the solution and all that. Okay, so suppose you have written a class by the name test. I mean, you can write anything, and this is your method. This is your first method. Don't look at the method definition. Method definition can be anything. We are only interested in method declaration. Okay, so focus your energy or attention on method declaration. So can you tell me, if this is the first version, if I write this as the second version, is it correctly overloaded? In short, Java compiler error or no error? Answer is no error. What is different here? Number of arguments are different. If I add the third version, error or no error? Ambiguity or no ambiguity? Answer is no error. Because here, if you compare it with this, type is different. Here, type is different. So fine. Next one. Oh, okay, so consider all these four. So far, I've already given you the answer. Compiler error or no error? Of course not. The number and the type is different. So there are 3 arguments and the different names also. But if you uncomment this, tell me why I'm saying there will be a Java compiler error. Because you have got a duplicate signature. Are you getting me? This? So this is a Java compiler error, definitely. Understood all this? Understood this? So I duplicate signature. Think like compiler. Compiler cannot resolve whether when you call this test method, whether to call this or whether to call this. So you will be saying, oh, there is a return type which is different. But is return type considered while resolving the overloaded methods? Absolutely not. Okay, so this was it. Now I'm asking you important question. Can you overload static methods? It's a Boolean question. Tell me, answer me. Yes or no? It's a Boolean question. So I want answers. Guys, you have to think a little bit before answering such things. I have shown you so many examples. Arrays.toString. So what is this method? Static method. So don't blindly answer yes or no. Think a little bit. Recall. Have you seen something? Of course, static methods can be overloaded. Okay. So there's nothing stopping you from overloading the static functionality. So these are all the trick questions. And anytime you are quoting your answering in an interview, always quote an example. So what is the example you will quote? Arrays class, arrays.toString. And you can tell the interviewer or whoever is asking, evaluator or whatever, you have arrays.toString to print integer array, Boolean array, primitive arrays, object arrays, etc. Okay, so this is your method overloading. More interesting examples I'll share as the question for today's lab. So let's have a quick recap and then we'll go to the next form. So start answering the questions. We are talking about polymorphism. So polymorphism is applicable to data members or actions. Answer is only actions. What are the two forms of polymorphism? Polymorphism means changing behavior, changing functionality. One is the static form, which is called as compile time polymorphism, which is called as early binding. And the other one which we are going to enter is dynamic form or a runtime form, or is called as the late binding. Absolutely. Tell me, who will resolve static binding? Compiler or JVM? Compiler. Who will resolve late binding? JVM. Late means at the runtime. It's a dynamic form of polymorphism. Okay, great. Now tell me, can you declare overloaded methods in the same class? Possible or not possible? Yes. Example, please. Which is the class and what is the name of the methods? Just now I quoted. Which is the class? No, don't say constructor. Aniket, I asked you what is the name of the class. Arrays is the name of the class and toString is the example. Or print stream is the name of the class and the print or println methods is the example, that way. But can I have, no, weak typing and strong typing I never said. You are off track totally. This one, Shubham. It's not related to polymorphism. It's typing is something different for the language. Don't mix up the issues. It's an irrelevant question here. Off track. Next one. What is it we were saying? Right. So here, when you say compile time polymorphism, is it achieved by method overriding or method overloading? L or R? Method overloading is the correct answer. Next one. What are the rules for overloading the methods? What about the method name? Same or different? Has to be same. What about the method arguments? Same or different? Has to be different. And when I say different, the number can differ, type can differ, or both can differ, right? All of them are applicable. And what about the return? No, don't say both. No, you did not understand me. Only number of arguments can be different and it is correct overloaded. Or I'm saying the type of the argument can be different. Or I said the both can be different. All of them are the examples of correct overloading. Okay, that way. How about this thing, return type? Return type is not considered during overloaded methods. So what if you write two methods with the same signature but different return types? Compiler error or no error? Compiler error causing the ambiguity. Okay, so this was your basic first look at method overloading. And I'm telling you, method overloading, I'm not saying it is not important, but it is not even half as important as runtime polymorphism. Because this is the heart of so many topics in Java. Let it be exception handling, let it be collection framework, let it be IO and all that. All this, if you don't understand runtime polymorphism and the terms like upcasting, downcasting, you face a lot of issues later. So today is a very important day. I mean, all the days are important, but especially. So coming back to the point, now we are entering actual object-oriented form of polymorphism, which is runtime polymorphism. So what are the statements? Runtime or dynamic polymorphism, or it is also called as late binding. What is another popular term people use for this is dynamic method dispatch. So see the word. I like specially, I use both. Runtime polymorphism is equal to dynamic method dispatch, but I like this term because it tells you a lot. So see this. What is the meaning of dynamic method dispatch? Which form of the method is to be used, is to be sent for execution? Who is going to take this decision? Java compiler or Java runtime? Answer that. Who is going to take this decision? Compiler, you are saying. Guys, method overloading, compile time, polymorphism is over. We are talking about runtime polymorphism. So that is going to be, this decision cannot be, read at least whatever I've written, cannot be taken by Java compiler. Why? Because you are going to have the same argument list. So I'll give you the string. What is it? Rules in a minute. It is beyond the Java compiler to understand which form of the method to send. It is taken by the JRE. To be precise, it is taken by your Java virtual machine, which is a part of JRE. And how do you achieve this runtime polymorphism? It is achieved via method overriding. So which is the example you have, I had given you in that fruit scenario, which is the method you have overridden in the subclasses? It was the toString also. There were two methods you had to override, guys. So don't give me one answer. toString as well as test, right? toString to display individual fruit details and the test method for supplying the individual fruits test. Okay, so you have, yesterday I just started with you all this, but today we are stepping back and understanding everything. So in short, method overriding is the way or the means of achieving runtime polymorphism, and this is nothing but your dynamic method dispatch. Okay, so now I'm talking to, if anyone is coming to me from C++ background, if you are not from C++ background, ignore my next 2 minutes discussion. But in C++, if you want to achieve runtime polymorphism, which is the keyword you have to add to the base class method, answer is virtual. Okay. So in C++, ever if you learn it or if you already know about it, unless and until you label, unless until you mark your base class function as a virtual function, you cannot achieve runtime polymorphism. Okay, so here is the news for you. Again, see, Java is simpler. So there is no virtual keyword in Java. What does it mean is all methods in Java are implicitly virtual. Read one statement at a time and understand it inside out. Is there, we have a JVM, Java virtual machine, but is there any keyword such as virtual keyword in Java? Answer is no. So what it means is all methods are implicitly virtual. So does that mean that all methods can be overridden? Answer is yes, unless and until something. Okay, so all these are extremely important statements. That's why I've given it in writing. I've given it in writing. So any Java method or all Java methods can be overridden unless and until they are marked as private or static or final. So I'll see it properly. So you know about private and static keyword. Final keyword you'll understand today. So let me see your understanding. We are talking about overriding. So this method overriding, let me ask you. Okay, before I ask you, I'll tell you. The method overriding means whenever you are following method overriding, the method name has to be the same. But here, the signature is also going to be the same. And return type also is typically the same, or there's something called as covariance. Forget covariance. So read only this much. The same method name, same signature, and return type same. So apply your common sense and tell me Girish, I'm coming to it. Don't ask in between questions. I have yet to say from my side. So here, let me ask you. Can you imagine, okay, what will happen? Or okay, I'll rephrase the question. Can you add this overridden and overriding methods in the same class? It's a Boolean question, yes or no? 100% no. The moment you say method signature is same, your compiler will shout for this thing, ambiguity. So that's not possible. So can you tell me, where will you have this method overriding? Where will you write? Where will you add this overridden method and overriding form? Answer is in the inheritance hierarchy. Inheritance hierarchy. So here in the base class, in the super class, what you write, whatever method definition, declaration and definition you write is called as overridden method, the one which gets overridden. And the subclass version is called overriding form. So tell me, object classes toString, what will you call? Overridden or overriding? E for overridden, I for overriding. Answer is overridden. And the person class has toString. What will you call? Person class has overridden the method. So it is the overriding form. But if you remember, person class as form is further overridden by student. So in student class, what is it you have got? Overriding form. So don't get confused in the terms. That's why I write it down. Superclass form, overridden version, the one which is overridden, and the subclass is called as the overriding form of the method. So I have given you sufficient information. Can anyone tell me why private methods cannot be overridden? All these are important questions. The question I'll repeat again. Why you cannot override a private method? Answer that. Wrong answer. Okay. So here, okay. Let me ask you. You're right, but I want to put it in a formal manner. What is method overriding? Inheriting the behavior and then modifying it. But tell me, can you inherit private methods in a subclass? Answer is no. And whatever you can't inherit, you cannot modify. Suppose, example, your parent or your grandparent has made a will and you are not part of that will. So you are not getting that property. So can you think of modifying or demolishing the property? Answer is not. Are you understanding the analogy? So whatever you don't access, whatever you don't inherit, you cannot modify. As simple as that. Next one. There is another interesting question. Static. Why static methods cannot be overridden, guys? There is a long readme I have supplied because it's a really important popular interview question. Static methods, tell me, are they associated with class level or are they associated with object? They are associated at the class level. So they are not associated with any particular object. And you will see in a short while that runtime polymorphism or dynamic method dispatch is decided by what is the type of the object which is being used. So static methods, since they are associated at the class level, they are not applicable for method overriding. Can static methods be overloaded? 100% yes. But can they be overridden? Never. And then you learn today another keyword in Java, final. So final methods means they are defined, they are declared and defined in their full and final form, cannot be changed further, cannot be modified further. Right now, don't focus on final keyword. I have yet to explain. So private methods, since they are not accessible, what you don't inherit to, you can't modify. As simple as that. And static methods, not associated with any object, so cannot be overridden. So now let us finally come to the rules of method overriding. Everyone knows the rules of method overloading. They were simpler. These are more. So for method overloading, same method name, I'm saying loading. Different signature, return type is not considered. Now note the rules to be followed by overriding form of the method, which you define it in a subclass. So read this slowly. Vinod, now I hope you got your answer. I'm telling you guys, you will get your answers if it is a relevant question. Somebody asked me strongly type, weakly type. This is not at all associated with inheritance polymorphism. So I'm not taking that question now. So method name has to be same. Signature has to be the same. And till JDK 1.5, we had a rule, return type also had to be same. So what all three things which have to be same? Same name, same signature, same return type. So tell me, what is it you are going to change between a superclass and a subclass? Overridden. Later, Yash, I have written it in the README. Static methods, why cannot be overridden? Read that. The method definition, functionality. So let's not call it as a functionality. Use the formal terms. So let me ask you. For method overriding, which of the following will be changed? First option, method declaration. Second option, method definition, body of the method. Both or neither? Pick up your option. Answer is method definition, body of the method. Okay, so this was the correct statement till JDK 1.5 was added. But from JDK 1.5 onwards, they have given you some change. So what is it they are saying is, the overriding form of the method either can have the same return type, or the return type of the subclass version, overriding version, can be the subtype. And it is called as the covariance return type. So nothing can be understood without an example. So have a look at an example. So have a look at this. Only read this much. Okay, so here I'm creating class A as a superclass. What is the method which is added here? Get instance. So what is the return type of this method? A. What is the access specifier of this method? Quickly. Which is the access specifier? Default, which is package private. Okay. So here, can default methods be overridden? It's a Boolean question, yes or no. Can default methods be overridden? Of course, yes, provided you are in the same package. Because default access specifier stops being visible when you step outside the package. So imagine both of them are in the same package. Okay. So class B extends A subclass in the same package. Mute yourself, guys. So here, if I write this, tell me, compiler error or no error? Or okay, I'll ask you a better question. Is this a correct form of method overriding or wrong? Correct form or wrong form? Answer is correct form. So check. Is the method name same? Yes. Is the method signature same? No arguments, that is same. Are the return types same? Tell me, same or different? They are not same, but is B a subtype of A? Yes. So what is the rule of method overriding? The overriding form of the method must have the same name, must have the same signature, and it may have either A as the same return type of above, or it can be the subtype. And sometime when I show you cloning in Java, I can give you the practical use case of covariance. Okay, so I'm going to give you some code examples. Code samples generally I like to share in the lab session so that we can discuss them together and understand it. So we are still into that, Abhijit. What is there not to understand is not, the topic is not complete. So I'm still doing that. So don't ask me to do the repeat things before I complete it. So method overriding is the form of runtime polymorphism, Abhijit. Your attention should be good. So it is nothing but modification of the behavior. Tell me, Abhijit, because you asked me and then I have to do this. So here, what requirements you want to change the super form? I'll answer this because I can't ignore such a basic level question. What is the need of overriding toString? Only Abhijit should answer because it is his question. What was the need of overriding toString? Because you said you did not get overriding. Respond faster because we can't waste your theory time. toString you have overridden yesterday or not? Wrong answer. You not understood. To modify the hash code printing version to replace the address returning version by the actual state details. So revise your yesterday stuff and then you'll understand it better. So method overriding is achieved, is used for changing the form at runtime. Okay, so I'm still not done. So with the examples, I hope you'll be clearer. Now the most important rule. Which are the rules I have given you so far? Same method name, same signature, return type can be same or its subtype. Next one. Now, what should be the scope of the overriding function, overriding method? Answer is, scope can be either the same as the superclass version or it can be wider. So without example, again, you don't understand. So let me ask you. Here, suppose the superclass method has the scope private. Will you be able to override it in the subclass? Answer is no. So private scope I'm not taking. But suppose the superclass version has the superclass method has the scope default. Can you tell me what all are the applicable scopes in the overriding form in a subclass? Yes, you are partly right, partly wrong. I mean, your just answer is incomplete. No. I'm asking you access specifier, guys. Access specifiers are private, default, protected, and public. So the correct answer is it can be default. It can be protected also. Today I'll explain you more in detail protected as well as public. Okay. So it can be anything which is same or wider. Answer the next question. If you have the method in the superclass with the protected access specifier, what are the legal access specifiers for the subclass version? It can be either same or wider. Guys, same or wider I've said. So either it can be same as protected or it can be public. But if the superclass method itself is public, which is the only access specifier you can use in the subclass, there's nothing wider than public. So you have to keep it as public. You cannot narrow down the scope. So for example, look at this. Example always makes it easier to follow. So wait a second. So what I'm going to do is you should be logging in at least with your computer. So if I ask you to change something or make a small change, you should be in a position to do that and not wait till the lab session. So have a look at it. Observe and conclude. Okay. So this was done for your yesterday's lab test. So observe here. Anyone wants to tell me why there is a compiler error? I did this right in front of you. So here there's a compiler error because the overriding, there's no range and all. Completely wrong answer. Not in scope is also completely wrong answer. Wrong. The rule is overriding form of the method. Okay, first of all, before I say the rule, tell me, is this a overloaded version or overriding version? L for loading, R for overriding. It's a method overriding. So those who are saying not clear method override, so many times I'm explaining the same because it's the same name, same signature, return type is also the same. So what is the rule? The rule is the scope or the access specifier can be same or wider. So which is the access specifier in the superclass version? Object class version public. So see in the compiler's language, they tell you so clearly, cannot reduce the visibility of the inherited method from object. What does it mean? The overriding form of the method's scope should be same as superclass or wider. Understood with the example? Clear with the example? Now see something, see the fun. Okay, so here I'm saying string something data and tell me why did error disappear? You can see that error has disappeared. Tell me why. Absolutely correct. It is no longer a method overriding, but it is method overloading. Can you see? See guys, this is how you learn. This is how I show Java. So here you have changed the signature. So now what is the rule of method overloading? They can be in the same class or they can be in superclass subclass. There is no rule regarding the access specifier for method overloading. But the whole idea is we wanted to achieve runtime polymorphism. So this is not what we had done. So I hope I'm making things clearer and not making it complex. So what is the rule of method overriding? I'll ask you just a second. Here. About method overriding, tell me the rules. I'll ask you. Same method name or different? It's important, so I'm repeating it so many times. So after that, don't tell me to repeat again. What about the method arguments, method signature? Same or different? Same. What about the return type? Same or, guys, same or covariant type. What is that covariant type? Same or subtype. I'll give you a better example in the lab session. Same or subtype and covariant type is also fine. And what about the access specifier, guys? That access specifier can be either the same as your super type version or it can be wider. You can never narrow down the scope. Means from public, you can't make it protected or default. From protected, you cannot make it default and likewise. Okay. So the scope has to be either, scope means access specifier has to be either same or wider. So these are the first couple of rules. And then there are, and then there are a couple of rules regarding exception handling. But you don't know what is exception handling. So this rule I can't show you, I can't show you now. So wait for exception handling and we'll discuss. There will be certain rules for method overriding and exception handling, but there is no rules corresponding to exception handling and method overloading. So I have prepared one slide for you. Today's reading homework, 100%. You have to go through this slide. So here there is a comparison between two different forms of polymorphic behavior, static form and the dynamic form. Who is detecting it and what are the rules? And the one which we were discussing is dynamic branch or late binding, or is called as dynamic method dispatch. So it can exist only in the inheritance hierarchy, means superclass and subclass. How do you achieve the polymorphic runtime polymorphism? Through method overriding. What are the rules for method overriding? All mentioned. Same name, same method name, same signature. Return type can be same or covariant type. The access specifier must be same or wider. You cannot restrict it. You cannot narrow it down. And this what do you say, final rule for exception handling regarding checked exception, we will discuss in exception handling topic. Because you don't know what is that checked exception, unchecked exception, all that. So other than exception handling, tell me, did you understand the rules regarding method overriding? Method overriding is way more important, 100 times more important than method overloading. Okay. So that is how I'm accordingly going to spend time on a topic depending on its importance. So this was your method overriding. Now I'm introducing a concept. Today I'm just introducing that concept of something called as annotation, and our entire advanced Java, enterprise Java, web programming in Java, second half of Java will be full of annotations. So here I'm explaining, I'm starting you. Of course, we will have a couple of annotations in core Java, but largely we will use them with advanced Java. So from JDK 1.5 onwards, like how they have brought in covariance, they have brought in annotation support. So first you have to understand what is an annotation. If you're coming to me from Python background, if anyone has a Python background, in Python we have decorators. Okay, so decorators in Python are nothing but annotations in Java. So understand that. The metadata. What is metadata? More information about the data. Okay, so annotations are nothing but the metadata, more information about the data, and it is meant for whom? It is meant for Java tools. So Java tools are primarily what? Java compiler and Java runtime. So throughout core Java, typically I'll be showing you compile time annotations, or compile time annotations or Java compiler metadata information. And in advanced Java, I'll be showing you runtime annotations. So now read further. Read this and I'll explain. Okay, so I'll start explaining. Java annotation is a tag. Tag is like a markup, right? So it is a tag or it is a markup which represents the metadata. So where all these annotations can appear, there are certain class level annotations, interface level annotations, method level, field level annotations. Today I'm showing you only one method level annotation, a tag which will come before the method declaration. So what are they for? To indicate additional information which you can supply to your either Java compiler or Java runtime. You will see in advanced Java, there are two ways to configure or to deploy your website application, server-side application. One way of deployment is using XML tags, but that time you'll realize for something simple jobs, you have to write loads of XML tags and remember them. So Java community these days prefers annotations. Annotations with a cool option is a very simple option, is a shortcut option as an alternative to XML. You won't understand it today. But I have to, when I say annotation, I have to give this background. When will you understand this? Directly in advanced Java. Because that is the time I'm going to show you. This is how you write it in XML file versus this is an annotation you have. So you will understand more there. But what are the examples? So any annotation we start with the tag, with the markup of @ and then follows the name of the annotation. And later you'll see annotations are nothing but interfaces. So when we go a little advanced, I'll show you how to create custom annotations, your own annotations also. So these are all built-in annotations, examples of built-in. So focus on only one thing at a time. So which is the annotation today I'm explaining is @ override. So let's have the question and answer. This annotation, is it meant for Java compiler or Java virtual machine as in runtime? Answer is, it is only applicable. This is the information meant for compiler. Is it going to come at the class level, field level, constructor level, or a method level? Answer is method level. And where it is going to appear? Is it going to appear in the superclass where you have an overridden function, or is it going to appear in the subclass where you have an overriding version? Answer is, it is going to appear in a subclass before the overriding form. And most important statement, is it compulsory to add this annotation in order to override the method? Absolutely not. So optional, but 100% recommended. So guys, have a look at it. Listen to this question. Tell me, is this a correctly or is it a correct version of a method overriding? Is it correctly overridden? Answer is yes. You have seen the output also. But did I add any @override annotation? Answer is no. So @override annotation is the extra caution. It is optional but recommended. And why it is recommended, I'll cover that in some other topic when I discuss the equals method with you. So now read further. So here, optional but recommended. Example makes it easy. So I hope you have read, or some of you might have solved that fruit example. So I hope you understand this. Is orange a fruit? Of course, yes. So public class orange extends from fruit. You got that? You must have declared some state that whatever. Oh, sorry. The state was already there in the superclass. Some constructors and all. That's not what I'm saying. So if you want to tell the compiler that whatever follows is the overriding form of the method, how do you tell compiler? How do you add this information to the compiler? Simply add @override annotation. So this is to tell compiler, see this, read, I've written everything in notes. If you want to inform the compiler that following is the overriding form of the method, what you have to do is use @override annotation. So when you use @override annotation, tell me what will happen if you don't follow method overriding rules. I'll repeat my question again. I said, if you add at override annotation to tell compiler that, okay, I'm overriding this from the base class, from the super class, and you don't follow some of the rules. As you commented for, I did not understand your question, Kunal. So here, you will definitely get the compile time error. Okay, so note your questions and talk to me in a clearer manner later. So here I'm still, again, I'm not finished with this. So tell me, I have not written any at override annotation, but is it still working? Yes. So that tells you at override annotation is optional, but why recommended, you will understand in a minute. Keep observing, guys. So here I'm saying string name. Tell me, can you see any compile time error or no error? Observe and conclude instead of asking vague questions, and questions which are vague means though I don't understand. If you ask me something in code, I'll definitely understand. Okay, so tell me, is there any compile time error? Absolutely not. You can see that there is no red crosses. So can anyone tell me why there is no compiler error? Because exactly, Pushkara just said it, compiler is thinking that this is your overloaded version. But guys, I did not want to do the overloading. I wanted to do the method overriding. It was just a mistake on my part. So, is there any way to tell compiler that this is not an overloaded form, but this is an overriding form? What is the way out? Answer is yes, of course, and that is where you add at override annotation. Now tell me, are you seeing the compiler error or not? Of course, compiler understands because compiler knows the rules. So which is the rule we have not followed? Access specifier, correct, same. Return type, same. Method name, same. But the method signature argument list, is it same or different? It is different. And this is what is the advantage of adding at override annotation. So I'm saying this again. Is at override annotation, is adding the override annotation mandatory or optional? M or O? Of course optional, but recommended so that you won't make your serious programming mistakes. Your errors will be caught at the compilation time. Tell me, out of context, I'm asking you, what is the, I need to know your mind. Which errors are easier to catch and solve? Compile time errors or runtime errors? Compile time errors. So bringing in the information, giving more information to the compiler, that is what we are achieving with the annotation. So initially, for the basic understanding of at override, this much is sufficient. But I'm telling you, currently you won't get sold in at override annotation. So just wait for my discussion on equals method to check the equality of two objects, and you'll 100% agree with me. It is a better, it is good to add the at override annotation. So observe something more. Okay, keep observing things, whatever I'm saying. So here I'm commenting this. Okay, everything is commented. And after you get the comfort level in overriding toString, say maybe in today's what? 4th or 5th day, maybe in 7th day, 8th day, whatever you take your call. If you say now I know how to generate constructors, I know how to generate toString, or rather how to write toString, there is an option to generate toString. Okay, so today, tomorrow, I would suggest don't use that option. Those who are completely fresh to Java should write their own code. But after you get confident, how do you do that? Source. Can you see an option here? Generate toString. And here it is asking you, which are the fields you want to include in the toString? So suppose I want both. Are you getting me? Source, generate toString, and you say generate. And as you know, IDE always write it in the most precise or most accurate manner. You'll definitely see at override being there. So I'll be silent for a minute. Think over what I said. And if there is something which is still bothering you, tell me. If there's some question, please ask. But ask a clear-cut question. You have to learn how to ask clear questions. Otherwise, I won't this thing. I won't understand your question and I can't help you then. So guys, don't exercise this option. There are so many shortcuts. There is a full code generation, template code generation, skeleton code generation. But today we are learning Java. We are in the first week we are learning. So generally don't use that. You got me? Any specific questions on annotation or so far whatever you have learned in method overriding? So this is it. So of course I'm going to comment this and I'm going to keep our own version, but that was just done to show you ID is also going to use. So my request to you all is not request, insistence to all of you is anytime you are overriding, anytime, just now Praveen, I did the whole thing. So I'm not going to repeat back to back things. You look at the code here at override, it is in front of you. So I'll repeat it directly in this. Same statements I'll not repeat 10 times. Maybe after 1 hour's break, I will repeat it for you, Praveen. Remind me after 1 hour because others will get bored. So coming back to the point, this is optional but recommended. And you saw the worth of it also. If you make any mistakes, 100% your compiler will detect it. And compile time errors are always easy to get than runtimes. Metadata is more information given to the tools. Wait for your database topic DBT. Metadata is more information about the data. So this tag is meant as the information to whom? Compiler or runtime. Not how many, there are tons of annotation. Nobody counts such things. So this is meant for your compiler. Wait for your advanced Java and you will learn so many annotations which are used by the Java runtime, which is on the web server or web containers and all that. So do limited things. Don't go beyond what is being discussed. Currently focus on the limited things, please. So let us move on to, no, it is not like a buffer. You are having your own ideas. There is nothing like buffer here. There's no buffering. It's just a tag. It is just a syntax. So don't apply your own ideas to things which you don't know. Okay. So now this is what is the I've just now discussed. You use it and you will have a better clarity. Don't imagine things here. So this was a first look at the annotation. Over time you'll get used to. So now I'm discussing runtime polymorphism or dynamic method dispatch in details, but I don't think you will understand this. Okay, so this is little theoretical. Let us apply to a business scenario for better understanding. So what we have done since morning is we did the revision. I showed you something about method overloading versus method overriding. We have identified the rules. So those I'll repeat sometime in the lab as a revision. And you have looked at the version of method overriding, and you have also looked at override annotation. This is what we have done so far. So now let us solve some business application, and trust me on this, you will start understanding all the theoretical concepts said so far. So what is our objective? The objective of first programming coding objective of today is creating event organizer app. So here, now this time, don't do anything. Stack Overflow and all, don't visit. This is not the time. When I'm discussing things, focus all attention here. So what I mean by that is, here, yes, I will do that, Abhijit. This doesn't have, Abhijit, you are using, I mean, of course, if you want it, I will send, not an issue. But all the things which I have said are in README inheritance polymorphism, which you should have started reading yesterday. Okay, so all these statements are in that README, which I have shared already yesterday. So read that. So coming back to the point here, what is it I want? So here, listen to this. I want to organize a meeting or a party or a get together or an event for the different persons. So which different persons? I want to organize an event for all the students and all the faculties. Here the requirement, don't think about something else or something what I said earlier. Otherwise, you don't understand what is going on at all and you feel lost. So we want to organize, we want to write an app as a Java application, which is going to organize the event. But for organizing the event, For organizing the event, you have to register for that event first. It's not like you just walk in. It's not a walk-in kind of thing. You have to register. So we are writing an event organizer app. We are going to write it together. And here, what will be the first question? Okay, sorry, before I ask about questions and all. So let me tell you here, what are the basic things? This is going to be, what do you say, increase over time, become more and more interesting over time. So this event organizer app should give the menu to the user, whoever is the organizer. He will get a registration from the student. A student wants to register for this meeting, for this get together, for this event, or a faculty also should be able to register. So whenever a student does the registration for the event, what should happen? The student details should be stored suitably. When a faculty registers for this particular meeting or for this event, what should happen? The faculty details. You remember this is a continuation of yesterday. So that first name, last name, years in experience or whatever, the subject matter expertise should be all stored suitably. And don't look at the words which, because I have not yet explained that. And then as an event coordinator, organizer, I as in our app, should be able to display all of the participant details. So this is our first objective of today. So just tell me first, do you understand? Did you understand the requirement? Is the requirement clear? Because if the question is not clear, you will not understand. Okay, so let me check how clear you are. So now is a good time to ask you. So how are you going to store the details of students as well as faculties? Which data structure you'll use? You don't have choices basically. All you know is array. Okay, so of course it is going to be the suitable data structure. Later you will have choices, sets, list, maps, or whatever in collection framework, data structure algorithms. So the suitable data structure is going to be the array. Okay, I'm guiding you one by one. So is it going to be, because people were solid confused yesterday. When I said point assignment, they were saying array of integers and all that. So tell me, this will be array of primitive types or array of references? P or R? Why you are saying, somebody said already primitive types. Wrong, guys. Here, you want to store the information about the student or a faculty. So tell me, guys, those who are thinking primitive, I'm talking to them. Is student a primitive type or a this thing, class type? I mean, reference type. Of course, it is a reference type. Student is a class. So student S is a class type of reference. How about faculty? If I say faculty F, what is F? Primitive type or reference type? Class type of reference. So those who are thinking primitive, stop thinking in primitives. So this has to be array of references. See, I'm arranging the topic in an increasing manner so that whatever you did on the first 4 days will be revised, plus you will see something. Okay, so it will be array of references, 100%. But now, what should be the type of the array? So the type of the array should be, I'm giving you choices. Should it be student or should it be faculty or none of above? None of these. The type of the array, should it be a student array? Should it be a faculty array or none of above? Answer is none of above. Why? Because if you create it as a student array type, let me say this. For student array, if you create it as a student array type, what will work and what will not work? Registering student, of course, works. I'm getting the student details and putting it there. But how can you add faculty details in the student array? Faculty type of a reference cannot be added to the student array. Understood or lost? Clear? We see, I'm telling you, if you just read the words such as dynamic method dispatch and all, nothing becomes clear. The moment you start applying it to the practical use case, everything falls in place. Trust me on that. Okay. Now the opposite question. If I create a faculty type of array, which will work and which will not work? Which option will work? Registering a faculty will obviously work. Faculty details added in the faculty type of reference, but registration of a student will fail. Everyone with me? Everyone understanding? Got this? So now I have to go to the common super type. See the one where I should be able to store student details, faculty details. Tomorrow a guest speaker joins us in our meeting. A guest speaker details, or your center heads details, or your course coordinator details, or your lab faculty details as well. So naturally, so answer is wrong. All these are the wrong options, invalid options. So can you tell me which is the correct option which will allow me to store student as well as faculty details? There is no participant array, guys. So don't use the words which is wrong. Participant is just the statement I have made here. So here, what is the type which is common, which is the common super type, which is above student and faculty is a person. And you will have to you will have to go to the common super type. And so the correct option which we will exercise soon is not a student array or not a, what is it called, faculty array, but it is going to be of the type person array. So when I say person array, individual type is of the type person. So tell me, can I say student is a person? It's a simple question. Yes, no. Of course, yes. Can you say faculty is a person? Yes, thanks to that extends keyword. So will I be able to store the student as well as faculty details using person type of reference? Answer is yes. And the principle behind that is called as upcasting. So if I start solving this assignment directly, it may not make sense. So first we always take an example, separate example of something called as upcasting, and then we will apply it to this. So what we are starting with is the discussion of a upcasting without making you read all those notes and all that. Everything is written, but I just want to show you with examples. So those who are coding along with me, follow the steps. Here, yesterday we had day 4.2. Guys, if you're not coding along, there is nothing to be feeling bad about. You can do the same thing, but in the lab session, your choice. So see what I'm doing. I'm clicking on day 4.2, Control C, Control V. I'm creating the first project of today, day 5.1. This is very important. What I'm telling you today and tomorrow, extremely important in your object oriented practices time. So I have made a copy. Guys, mute yourself immediately. So 4.2 copied into 5.1. Now let me throw away the stuff which I don't require. So I'm requiring this. I'm going to require. I don't require this. So let me. I just did this copy so that I don't have to write everything again. I don't want to. And this also is not required. Okay. So just observe what I have retained. All I have got is I've closed everything else. So I have got a person which we have written together. Now let us be smart and use at override. So all these extra things I'll remove. So at override here, definitely. Let us go to your student. You know this, we have written it together. I have revised it also, whatever in the lab session. So tell me, can I use any annotation? Can I use at override annotation above this method as a metadata, as a markup, as a tag? It's a yes or no question. Of course, yes. This is the overriding form. So this is your overriding form of the overriding form of the method. So 100% add. So if you're coding along, please keep adding at override annotation. And you just have to take the cursor here and it will give you the help. Or better thing is you can simply search here for override. And you will see in java.lang, you will see the annotation by the name override, and you can read the details. Okay, so there is a lot of information in Java docs. Going ahead, let me open the faculty class. Tell me, is this the overriding form of the method? Overriding form of the toString? Yes, again. So please add, get used to all these things on one day. Whenever I show, now follow those norms, follow those design principles. So add override again. Okay, so these are the basic changes I did. Now let's start with the interesting stuff. So here in the tester package, I'm going to create test. I mean test 1, test 2, test 3 I'm going to create. So now focus here. What I will do is just copy that data from yesterday so that I don't have to write it. Just observe, please. Here. This is the yesterday's thing I have copied. So I don't want to like do too many things. I'll just pick up the basic things. We'll bring in the faculty things later. Nothing difficult. I'm starting with a extremely, what do you say, simple example. So tell me, here in this line, what is the type of the reference and what is the type of the object? I'll repeat the question again. In this highlighted line, what is the type of the reference and what is the type of the object? Reference type is no. Okay, and I did not ask you the reference variable name. I said, what is the type of the reference? Student. What is the type of the object you are creating? Student. So are we at the same level or are we somewhere up and down? Are we at the same level? The reference type and the object type are at the same level. So here guys, here I'm introducing 4 terms. Okay, so look at this. Super type reference. So okay, I'll say this. Super type you will not understand today. Super class reference, super class object, subclass reference, and subclass reference and subclass object. Okay, so here are the 4 things. And if you are wondering which superclass, which subclass she is talking about, our hierarchy. So which is the superclass, guys? Person is the superclass and my student is the subclass. So tell me, now answer. Here, which type of reference is pointing to which type of object? You have to use these 4 options, one of these options, 2 of these options. I'll repeat the question again. I want it as superclass reference pointing to superclass objects, superclass reference pointing to subclass object, etc. So give me the answer. Here in this line, which type of reference pointing to which type of object? I want the 2 words, subclass reference pointing to subclass object. So are we going anywhere up or down in the hierarchy? Answer is no. So here, what is the answer you gave me, which is correct answer? Subclass reference pointing to subclass object. Okay. And since we are at the same level, type of the reference and type of the object is the same. This is the example of direct referencing. So this is called as direct referencing. Why it is called as direct referencing? Because I'll keep it at the top. Since it is the type of the reference and type of the object is the same. Clear so far? Are the terms getting clearer? Because you people use. No, don't go ahead of time, Kunal. People are not knowing Java here. So here, is the stuff clear? Is the statement clear? Is it a direct referencing or is it an indirect referencing? Tell me. It's a direct referencing. Type of the reference, type of object, all same. So here, guys, when I say this, okay, student1 dot toString, there is zero ambiguity. Which classes toString will get called? There's no ambiguity. There is nothing to be decided by the runtime. Students toString gets called, is invoked. Whatever I'm saying, I'm writing. So you don't have to wait for recording and all that. So of course you observe it. So as already discussed yesterday, as seen yesterday so many times, are we correctly getting all the student details from that? So here you are getting the correct details from the students toString class. Everyone 100% clear so far? Things are going to change. So I'm going extremely slow for an important concept. So this is it. Students toString is invoked. Now, when I talk about, so this is your direct referencing. Now we are talking about something else. You'll know in a minute. So see this. I'll say person P. So I'm saying control shift row, which will bring in the imports. It has imported this. Okay. Oh, sorry. Before that, I want to make a statement. I was thinking, but somebody unmuted and I forgot what I was saying. Here. Now see the beauty. The beauty is when you are using system.out.println, you don't have to explicitly call student.toString. ToString can be removed. But implicitly, it is going to call student1. What is it? It is going to call internally student1 dot toString. How that happens is a popular interview question. Answer is in Java docs. So I'll give you that as a reading homework. And tomorrow I'll give you the answer. If none of you can find it, I'm sure you will find it. So let me, I'm not yet going to upcasting, downcasting, nothing. I'm still in the direct referencing. So what will happen here is when you pass, how happens later, when you pass to this println, any reference variable, automatically its toString is called. So please confirm and tell me, are you getting the same output as earlier or different output? So everyone is clear? Don't say super. Okay, maybe that was something else. So here, this is all simple. So only thing which I change here is I don't have to explicitly call toString. Automatically, it will call student1.toString. I'll say this here implicitly. How? That's a question for you to solve. I'll give you help in the lab session. So this much is done. Now let us go beyond. Let's go further and let's do this. I say person P. So can anyone tell me what is P? Guys, mute yourself. I don't know why you are unmuting yourself all the time. Don't do that, please. So is it I need an answer. Is it a primitive type or reference type? I already got the answer. Reference type, absolutely. But what is it? What is it? Can you pick up one option for this? It is nothing but a super class reference. Very good going, guys. So here it is, super class type of a reference. Everyone agreeing with me? Okay. Now the interesting thing.
Hello.
So now, see guys, it gets disturbing when you start in between unmuting yourself and cause confusion. Please don't, because it breaks my thoughts. So please don't do that. Follow some decorum here. So I'm saying now, important thing, P is equal to student1. So the question being asked is, after adding the semicolon, compiler error or no error? You're not supposed to add the semicolon and test it. You are supposed to tell me without this thing. Answer is, there is no compiler error. Okay. So just observe things. It's a very important topic. So I'm going super slow on this. What is that? It is always right associative. You know the RHS to LHS. So anyone wants to tell me what is the type of the RHS? What is the data type of RHS? It's a student subtype, subclass, right? And when you go from RHS to LHS, are you climbing up the hierarchy or are you climbing down the hierarchy? It's a simple question I'm asking you. Of course, you are climbing up the hierarchy. And why does compiler allow you this assignment implicitly? Because compiler goes by is a relationship. So can you say, can it find out every student is a person? What's the answer to that? Is every student going to be a person? Yes, student extends a person. So this is nothing but your upcasting. What is upcasting? Upcasting is the implicit cast added by, tell me, added by compiler or added by Java programmer? C for compiler, P for programmer. Compiler. Implicitly, the moment I said implicit, you know that added by the Java compiler or Java C, while it is nothing but that cast. And here, why this works? This works because the student extends person, or you can say that every student is a person. Okay, so 100%, this is a working example. Okay, so you are climbing up the hierarchy, and compiler just goes by the fact that student extends a person. So every student is a person. Okay, so this is your example of upcasting. In primitive types, you remember I had given you the widening conversion. Can you give me an example of automatic promotion such as widening in primitive types? This is all related. That was in primitive types. Exactly, Kunal. Right. I just saw your message. Yeah, short to end or byte to float or long to float. So, but don't mix up these two. That was primitive type. So leave aside. This is while we are going from student to person, climbing up the hierarchy, upcasting. Totally done by the compiler. Now comes another most important statement of the day. So when I'm going to say sys out P. Okay. So here, this is an important statement. So when I say, when I add println P, what will it implicitly call? P dot toString. When you say println and pass any reference, it is going to call toString. So now listen to the question very carefully, or listen to the next statement carefully. When you are in Java, there are two things you have to understand: how Java compiler works, how Java runtime works. So important most statement is Java compiler goes by the type of the reference. So anyone wants to tell me what is the type of this P? Wrong answer. Type of the reference I'm saying, guys. What is the type of the P here? Person. So what will Java compiler check? Java compiler will check, is there a toString method in which class? In person class or in student class? In the person class. So it will literally check in the person class, there is a toString. Even if you comment it, it will use it from that inherited version from object. So compilation is passed. So here I'm saying, I'll give in writing. The whole thing is already written down in the README inheritance polymorphism. So here, Java C resolves the method binding by type of the reference. So what is the type of the reference in our case? Person. So compilation succeeds. That is why you are not getting the compile time error. But guys, here we are talking about method overriding. ToString is the overriding form of the version. So we have another statement coming up, but or later you can say JVM resolves the method binding by not the type of the reference, but the type of the object it is referring to. So JVM resolves the method binding by type of the object it is referring to. So tell me, when I say P is equal to student1, can you tell me what is the type of the object where the reference is actually pointing to? Is it a person or is it a student? Answer is it a student. And JVM will, so to complete the story, when I execute this, for compilation it has checked, but when I run this, which classes, which method. So which objects, which method will be called? The toString method will be called, that is decided. But it will be called on which object? Person object or student object? Answer is student object. And this is nothing but the example of runtime polymorphism is equal to dynamic method dispatch. So see guys, here we have just said SOPP, but JVM is figuring it out depending on type of the object it is referring to. It is not decided. It cannot be decided by the compiler because compiler finds person's toString, finds it happy. I mean, it is happy. But JVM is going to decide by the type of the object. And when I run this code, here, see, SOPP, will you have the same output as line number 14 or a different output? Same output or different output? 100% same output. But then what is the difference? This you have achieved via direct referencing or indirect referencing. Line number 14. Direct or indirect? Of course, direct. And this you have achieved via direct referencing or indirect referencing? Indirect referencing. And if you are wondering that where she is going with this, we are going for this. Soon you are going to have a real life example where you have to deal with student objects, faculty objects, guest speaker objects, lab faculty objects and all. And you have to handle it in a common manner. That is where you will require completely upcasting. So this is a real life example. This is just a warm up. So let me just run this. And as you can see, both the details. So how we have fetched these above details? Direct referencing or indirect referencing? Answer is direct referencing. What is the meaning of direct referencing? Type of the reference and type of the object is the same. So you're not climbing up or climbing down any hierarchy. How about the next one? How have we achieved these details? Indirect referencing. Superclass reference was pointing to subclass object. Guys, I'm going to say all of this throughout today, 100 times minimum. So you will definitely get it by the 100th time, I'm sure at least. So here, type of the reference, person. So here is the question, here is the statement, superclass reference is pointing to your subclass object. You'll say where it is. It is a subclass reference, agreed. But this subclass reference is pointing to subclass object. So what is the thing here? Superclass reference pointing to subclass object. I'll just talk in C++ so that, from C++ also you can connect to it if you know C++. What we do in C++, we write a base class and tag the method as with virtual keyword. And then we override the method. We do the function overriding there. It is called as function. Here it is called as method. And when you have a base class pointer pointing to derived class object, which method gets called is the overriding version. So whether it is Java, C++, Python, runtime polymorphism is the same. So this was my statement. I'll just write 2 more lines and let's see whether you can observe. I mean, you can give me the correct answer or not. So let's do this. Now I'll do it in slightly different manner. P is equal to, give me a sec. I don't want to type the data again. That's why. Your just job is, tell me, after adding the semicolon, compile time error or no error? Currently it is showing you compile time error. So will there be a compile time error? This is of course no error. And anyone wants to tell me why? One word answer. What is the reason behind it? Upcasting. Absolutely correct. It is nothing but an example of upcasting. Tell me how it is upcasting. Tell me what is the RHS type? Faculty. What is the LHS type? Person. Okay. So what is it we have got? Direct referencing or indirect referencing? We have got indirect referencing. Superclass reference pointing to subclass object. Can anyone tell me why compiler allows this upcasting? Because of extends keyword. Can you say every faculty is a person? Yes. Thanks to that is a relationship, extends keyword inheritance. Compiler allows it. Compiler places that implicit cast and allows it. You don't require it. Just like somebody said, widening in primitive types. Okay. So now the next question, and we are off for a break. So when I say sys out P, can you please tell me? Okay, first thing I will say. So this expands to P dot toString. So can you please tell me what will compiler check and what will JVM? Don't give me both the answers. Just tell me what will compiler go by. Will it go by the type of the object or type of the reference? R or O? Compiler goes by the type of the reference. Means what? What will it check is, will it check in which class it will check for toString? Compiler, person, student or faculty? Answer is person. Absolutely right. So tell me, do we have in the person class toString? Yes. So compiler is happy. Compiler says, okay, this is all I understand. But now comes the JVM. So tell me, JVM goes by the type of the object or type of the reference? JVM goes by the type of the object. Very right. So now, what is the type of the object? Your choices are person, student, or faculty. Everyone knows the answer. It is the faculty. So the last question is, when you write this, you are using nothing but runtime polymorphism, where the method toString to be called on which type of object is decided at runtime. So what is it? Dynamic method dispatch. In simple words, what will be the output here? Your choices are hash code version, first name, last name, students' complete details, or faculty's complete details, or none of above. Of course, faculty's complete details. And that is where we take a break. So this is the beginning of a very, very interesting topic: indirect referencing, method overriding, and upcasting. So I hope you can see this here. Using indirect referencing, person type of a reference is accessing the faculty details. Here, person type of a reference was capable of finding the, what is it called? Student details. So last question, really last question before dispersing. In this piece of code, are there any objects marked for garbage collection? It's a Boolean question. It's unrelated question, but I just felt like asking you. Answer is no. Why? Because you are absolutely right, by the way. So tell me, is the student object marked for garbage collection? Answer is no. Why not? Because see, you have reassigned P, but there is a copy. That student one is still pointing to student. So you're absolutely right in answering. There are no objects marked for garbage collection. And where is actually runtime polymorphism happening? In line number 18. This is a dynamic method dispatch as well as line number 21. So what I'll do is, which I do always, I'll share. You already have that person, faculty, and all that. I'm sending you this code over chat. So anyone wants to play with it in the break itself can go ahead. This is our D5.1 SRC test 1. So I've sent you this test1.java where I've shown you the upcasting, and we'll apply it after the break. And somebody wanted those readmes also. So that readme inheritance polymorphism is already shared yesterday. I've not made many changes, but if you want this sequence document, which is not much, but if you want it, I can always share. So in the today's help, but that is yet, in process. I mean, I'll be adding more to that by the end of the day. For Java help, D5 help, that sequence document. Okay, so both are shared. You pick up, you check whatever you want, and we will resume at 11 o'clock. So that will be all. Whatever questions, whatever queries, I have not yet finished from my side, guys. So allow me, give me a chance to finish a particular topic. And then, of course, you can come out with all your queries. That will be all. See you around.